Okay, in this video we're going to take a look at some business examples of optimization. Okay, so businesses are generally in the business of trying to maximize their revenue or their profit. Those are two different things that we'll talk about in a moment, and minimize their costs. So here are the different functions we're going to have. First of all, X is going to be our variable here. It's going to be the number of items that we're going to produce. So we're manufacturing something that we're going to try to sell. C of X, that's our cost function. That's going to be the cost to produce X products. And if we take its derivative, that's called the marginal cost. So in the business world, the word derivative sort of becomes the word margin or marginal. The derivative of the cost is the marginal cost. P of X, that's our demand function, or it's also called the price function, which is why we're using a P for it. That's the price the company could charge if it was going to sell X units. And that corresponds to X, which is the number that we're going to try to sell. We are trying to get it so that this X is the same as this X, so that we're selling everything that we produce. Because if we produce a whole bunch of objects and they just sit on the shelf and we don't sell them, we have spent money to make them and we're not getting any money from selling them. Okay. Now, it might be advantageous to overproduce by a little bit so that customers don't have the experience of, oh, it wasn't at this store, I have to go to that store to get it, all of that. But we're going to simplify things and just say we're trying to sell everything that we manufacture. So we're trying to set the price so that we can sell everything that we make. And it kind of makes sense that the number that we can sell is going to depend on the price. Because if I was selling whiteboard markers, okay, and I was selling them for $1 a piece, I imagine some people back in the glorious days when we could meet at the LRC and study and write on whiteboards together would say, hey, I'd like a whiteboard marker. I've got an extra $1 lying around. Okay, I'll buy a whiteboard marker because it's not that expensive and they'd be okay doing that. Okay, but if I was selling this for $100, you'd have to be pretty desperate for a whiteboard marker in order to decide that it's worth the price. Okay, so basically the bigger the price, the smaller the number of units that you're going to sell. Okay. Then we've got our revenue function. Okay. Revenue is just the amount that's coming in. So if I sell something, I get paid for what I'm selling, and the revenue is just the number that I'm selling times the price per that number. So it's X times the price of X. So we say that that's the revenue that's generated by making and selling X products. Okay. That I said is different from the profit, because P of X, which would be my profit, is going to be the revenue minus the cost. So it's the money coming in minus the money that I had to expend in order to manufacture things. And so this is our profit. Okay. Overall, businesses are generally trying to maximize their profit and minimize their costs, but often they're going to just take a look at what's our revenue, let's try to maximize that. So make sure you're reading the questions carefully to see whether you're trying to maximize a revenue or a profit or to minimize a cost. Okay. As with the cost, with both revenue and profit, if I take a look at R prime of X, we call that the marginal revenue. And if I take a look at P prime of X, we call that the marginal profit. So, these derivatives are basically giving us, of course, a rate of change. So if I were to produce more objects, would my profit increase, in which case I might have an incentive to produce more objects, or would my profit decrease, in which case I probably don't want to manufacture more products because I'm going to be losing money as a result of working harder, which doesn't seem like a very good decision. Okay. So that's all of the vocabulary that we have. Now, I'm going to just do one of the even numbered problems from our homework. So I'm going to take a look at question number 60. And it's a two-part question. The first part deals with profit. So they said profit, remember, is revenue minus cost. Okay. And the first part just says, hey, show that if you're maximizing the profit, that the marginal revenue and the marginal cost are equal to each other. Okay. Well, let's translate that into math. If we're maximizing profit, that would mean that the derivative of revenue and the derivative of cost would be the same. Well, if I were trying to maximize profit, I would take a look at the derivative. And of course, that would just be R prime minus C prime. So the marginal profit is the marginal revenue minus the marginal cost. Okay. If profit is maximized, now without a specific function, I'm not going to have the tools to be able to see whether I'm getting a max here, but if profit is maximized, that's at a critical point, at a critical number. Okay. And supposing that these are all differentiable functions, that's going to mean that p prime of x is going to equal 0 if p, r, and c are differentiable, which in general we're going to suppose that they are. Okay. So in theory I could have a critical number because the derivative is undefined, but assuming my critical number is at a place where that's 0, that would just mean that r prime of x minus c prime of x would equal 0, r prime of x would equal c prime of x. Okay. So I think the hard part in that problem was just translating from marginal revenue equals marginal cost to, hey, this derivative has to equal this derivative, because the derivative of profit would have to be 0 if I'm at a max. Now, of course, this would also be true if profit was at a min, okay? So I'm not claiming that if this is true, you have a max. I'm just saying if you have a maximum profit and your profit, revenue, and cost functions are all differentiable, then you will have the situation that the marginal cost is equal to the marginal revenue. Okay, the second part of the problem gives us some specific functions. So they're going to give us that the cost function is 1600 plus 500x minus 1.6x squared plus 0.004x cubed. And they're going to give us that the price function is 1700 minus 7x. That's the price function, or again, I could call that the demand function. Okay. And what they're asking us to do in this case is find the production level so that would be the x value. That's the number that we're going to produce that maximizes profit. Okay. I'd encourage you to pause the video and see if you can work this one out and then come back and rejoin me. If you want to watch a little bit longer until we get the formula for profit set up, that's totally fine too. But I would encourage you at some point to pause the video and try to work it out on your own. Welcome back. Okay, so profit, we said, is just going to be revenue, the money coming in, minus cost. Remember, revenue is x times p of x, the number that we're going to sell times the price. We're supposing that we've rigged the price so that it's going to meet the demand so that we can sell everything that we want to. Okay. So we've got that profit, the thing that we want to maximize, is given by this, and we were given the price function and the cost function. So this is going to be x times 1700 minus 7x minus, in brackets, because I'm going to subtract that whole thing, 1600 plus 500x minus 1.6x squared plus 0.004x cubed. Okay. All right, now one thing that's nice about this, that's the thing I want to maximize, and I don't have a constraint. That's already just a function of one variable. I will point out that my domain is everything from 0 to infinity, because x is representing the number of products that I'm producing, and I can't produce and sell a negative number of objects. Okay, so I do have a restricted domain. That's important because when I'm looking for critical numbers, I'm not going to include anything that's a negative number. Okay, so let's see. I think I want to multiply this out. What happened to my eraser? Here we go. I want to work that out and take the derivative. So I'm going to have p of x. I'm going to distribute the x, and then I'm going to distribute the negative. So I'm going to get 1700x minus 7x squared minus 1600 minus 500x plus 1.6x squared minus 0.004x cubed. Before I take the derivative, let's just combine some like terms. So let's see, I've got here some x's and some x's. So that's going to be a total of 1200x. This is minus 7x squared plus 1.6x squared. So that's going to be minus 5.4x squared minus 0.004x cubed and minus 1600. Okay. So I was able to combine some x's and some x squareds. Okay, so if I take a look at p prime of x, that's going to be 1200 minus 10.8x minus 0.012x squared, and then the derivative of this constant, of course, is just 0. Notice that that's always defined. Okay. So I want to look for where this thing is 0. So I've got negative 0.012x squared minus 10.8x plus 1200 is equal to 0. That is just a quadratic equation. So I can find my roots for that quadratic equation. X is going to be the opposite of negative 10.8, which is 10.8, plus or minus the square root of negative 10.8 squared, which is going to kill off the negative, minus 4 times negative 0.012 times 1200, all divided by 2 times negative 0.012, which is negative 0.024. These are going to be my critical numbers. Now, that's a messy enough number that I am going to go ahead and use a calculator to get a decimal approximation for these. These problems were actually set up to use realistic numbers as opposed to the nice numbers that I usually use so that we don't need a calculator. So we've been going for a little while. I'm going to pause the video. I'm going to come back after plugging this into a calculator, and we'll finish up the problem then.